Arav.
I gave an intro.
Okay, let's continue, people. Last class we stopped at isomerism in coordination compounds. Before we move ahead with nomenclature, let's first do some numericals, and we had to do thoda sa numericals on CFT भी. CFT पहले किया था, but थोड़ा एक दो अलग questions भी करेंगे. Now let's start with the first question. क्या बोलता है people वहाँ पे? The first question, give the possible isomers of COEN twice, Br, Cl, SO. So chalo, let's understand how do we do this. So you have to people first consider both geometrical, optical, stereo and structural, सब compare करना होता है. What we'll first do is we'll first write its general form. So this is cobalt. So cobalt के यहाँ पे क्या लिखा हमने? M. This is AA2BC. That's the first thing that you should know. This is MAA2BC. Now, पहले इसकी structural isomers try करते हैं. I can have another isomer which is something like this. Counter ion can behave like ligand and the ligand can behave like counter ion. Which type of structural isomerism was this? Excellent. Ionization isomerism. Very good people. So this is ionization isomerism. So what we first wrote is iska people, we can have this as the ionization isomer. Can we have one more ionization isomer? Batao. COEN twice. You have Cl, SO4 and then Br. Samjha. Can we have any other structural isomer out of these? कितने structural isomers किए थे? We started with ionization, hydrate or solvate, linkage, coordination, polynuclear coordination, and then ligand. Yes or no? Very nice. Okay. Now, MAA2B2. I'm sorry, MAA2BC. This has two forms. Kaun sa people? This can have a cis form. Excellent. And this has a
Trans.
and we know that the cis form is optically active. Excellent. Trans form is optically
Inactive.
very nice. Which means that cis can have a D form, it can have a L form. Sanja? So the first isomer or the first compound here can have how many different forms? 3. D, L and the trans. Then uska linkage can also have, and then uska linkage can also have. So the total answer here is the possible number of isomers are 9. Anyone who did not get that? ऐसे question आता है. You can also get independent question like सिर्फ structural isomers पे, but this clubs both structural as well as stereo. समझा? Let's do the second one. Second one क्या बोलते हैं people? देखो एक बार. I'll keep the answer for the first one यहाँ पे. चलो. This is CONH3,4Cl2. इसका कौन सा फॉर्म लिखेंगे हम? M A4B2. Quickly go to M A4B2. is Ma4B2 optically active or inactive? Excellent. It is optically inactive. Very nice. Which means this has only the cis and trans form. जो इसको बना तो नहीं रहे because already उन्होंने हमें बना के दिए हैं. चलो. These are the 4 forms that they've given us. So इसको कैसे start करेंगे? इस वाली का रिमोट है क्या इधर की? चलो. So how do you start this? Let's compare. First statement. We have to find false statement out of the 4. First, 2 and 3 are cis and trans. Is it true? 2 and 3. Yes, because if I look at Cl, this is Cl cis. Okay? Because the angle between Cl here is 90. The angle between Cl here is. तो मैं बोल सकता हूँ yes. This statement is true. तो true है. What about B? 3 and 4 are trans and cis. Yes, same thing again, people. This is Cl trans and this becomes Cl cis because Cl के बीच में 90 degree angle है and over here Cl के बीच में the angle, people, is. So this statement is also 1 and 2 are enantiomers. What were enantiomers? Excellent. Non-superimposable mirror images of optically active compounds. Excellent. So, this is optically active या inactive? Ma4B2 तो optically inactive है. तो enantiomer कहाँ से आ गए? You will get that? Yes, all are identical. That statement is also true. Yeah, they homomers. They all are identical. समझा? ठीक है. हाँ. Same compound के structures. अगर optically active होते तो that would have been तो third statement भी true होता 1 and 2 अगर optically active होते तो. Now let's look at the next question. Yeah, I want you people to do it. Structure बना के देता हूँ. The total number of N, Mn and Cl bonds, sorry, bond angle, which is present in what position? Cis मतलब what angle are we looking for? 90 degrees. Present in the molecule cis M En twice Cl twice. So that is of which form? MAA2B2. तो इस MAA2B2 का स्ट्रक्चर कैसे था? तो यहाँ पे ड्रॉ करते हैं. चलो. So this is Mn. B2 is Cl cis position. And the rest we have ethylene diamine NH2, CH2, CH2 and NH2. Next. NH2, CH2, CH2, NH2. That is the cis form. अब question क्या पूछा है? What degree angle do we have to look for? 90 degree. And angle is N, Mn and look at this. Cl, Mn, N. What angle is that? How many such angles are there? Number करते हैं. Let's say I'll number this as 1, 2, 3, 4, 5 and 6. If I start from 2, go to Mn, then I go to 1. What angle is this? Such these 6 angles are we looking for? तो ऐसे total कितना है आप मुझे बताओ. This is 90. Can someone give me one more 90 degree यहाँ पे? Starting from 2. 2 Mn and 6. 2 Mn 5. 2 वाला और कोई बना सकता है कि 90 डिग्री? 2 वाला, 2 से स्टार्ट करने वाला. नो. अब नेक्स्ट सीएल कौन सा है? सो 3 Mn 1, 3 Mn 6, and 3 Mn 4. All these angles are also. So total कितना हो गया? 3 here and 3 here. So total number are 6. Did you people get that? Anyone who did not get this? 2 Mn3 will be with a Cl Mn Cl bond. Question बोलता है N Mn Cl bond. अगर क्वेश्चन होता Cl Mn Cl bond तो वो होता. ये समझा क्या रे? Anyone did not get that? चलो. अच्छा. Okay, match the column. A. A का फॉर्म क्या है? M A2 B C. Is MAA2 BC optically active? Excellent. Yes, it is. Since it is optically active, will it show enantiomers? Yes. Will this show geometrical isomers? Yes, यहीं पे सेम ही था MAA2. तो cis and trans दोनों तो इसमें excellent. 2. Can it show ionization isomers? Yes, I can swap the position of Cl and SO4. Yes. Can it show linkage isomers? For linkage isomers, we need ambidentate ligands. Excellent. So, are there ambidentate ligands over there? तो बताएगा क्या? So, A का क्या क्या है people? 1, 2, 3. And then next try B वाला. M A4 B2. M A4 B2 ऑप्टिकली एक्टिव होता है या ऑप्टिकली इनएक्टिव होता है पीपल? इनएक्टिव. Since it is optically inactive, will it show enantiomers? No. But will it show GI? Yes. Will it show ionization isomers? Yes. NO3 अंदर NO2. So ionization. Will it show linkage? Excellent. Yes. NO2 can be written as ONO. So 2, 3, 4. Next C वाला CO EN PN. PN क्या वाला people? Propylene diamine neutral bidentate. So which form is that? M A sorry MAA2 भी लिख सकते हैं वहां पे and B2 because propylene diamine is also a symmetric bidentate एथिलीन डायमीन भी एक सिमेट्रिक बाइडेंटेट है. MAA2B2 और ये दोनों सेम हो गए. Yes or no? So will it show enantiomers? Yes. Will it show GI? Yes. Will it show ionization isomers? Yes. And it also shows linkage because this NO2 can be written as ONO. And the last one, D wala, is M AB thrice. M AB thrice does not show any GI, but it shows optical activity. Will it show any ionization isomer? Will it show any linkage isomer? This is the answer for match the column. चलो, बिफोर वी मूव ऑन टू द नेक्स्ट वन, पहले इतना कॉपी कर लेना एंड उसके बाद वाला क्वेश्चन आप करोगे, द टोटल पॉसिबल आइसोमर्स. एक सेकेंड ना. Oops. Okay, that was first. अभी second question करते people. Total number of possible isomers मैं clear करता हूँ. Yeah, we'll do one thing. Okay. So second, calculate total number of possible isomers for the first one. What's the first compound, people? M. Chalo. So this is M. A, B, C, D. Chalo. Give me M, A, B, C, D has how many isomers? They have only GI. They don't have OI. कितने GIs थे यहाँ पे? Excellent. 3. M, A, B, C, D. Now we have to check for different structural. Will this show ionization isomers? Isomerism? No, कुछ है ही नहीं ionization sphere में तो क्या दिखाएगा? Will it show hydrate isomerism? No. Water किधर है? But it will show linkage. अब कैसे दिखाएगा? Pay attention. M, F, Cl, SCN, thiocyaneto is also isothiocyaneto. Did you people get that? So this will also have 3 different forms. Yes. Next may M, F, Cl, SCN, but NO2 is, oh no. Samjha, this will have 3 trace. And finally M, F, Cl. Now S, yes, both will be in its ambidentate form. दूसरा NCS and oh no. Total कितना हो गया? You will get that. All these are almost PYQs.
Almost like this.
थोड़ा modification कर दिया एक दूसरा. Did you will get that? The B वाला is homework. गृह कार्य आप लोग करोगे at home. Arrange in decreasing order of splitting energy. Remember we did spectrochemical series, excellent open spectrochemical series. Okay, people. Chalo. So what we have to just do over here is decreasing order splitting energy के लिए we need the strength of ligands. So tell me, यहाँ पे we have H2O, CN, Cl and NH3. What was the trend in strength of ligands? Which was the strongest? The carbon donors, so CN है. After that, nitrogen donors. Then we have oxygen donors, the oxygen को है ही नहीं. And then we have H2O, sorry, oxygen donor, H2O. And then last, the weakest of the is Cl. So this is the energy of the ligand. अब आप मेरे को बता सकते हो so सबसे ज़्यादा crystal field splitting किस में होगी? 1, 2, 3, 4. So 2, then we have 4, then we have 1, and last में we have 3. Did you will get that? Yes or no? What about this? Same ligand. But what do you observe here? Cobalt belongs to the 3D series. Cobalt के नीचे आता है rhodium, and then we have iridium. Now यहाँ पे remember we wrote a note. All the exception के बाद we have written a note. All the exceptions in CFT. In case if the metal belongs to 4D and 5D series, all ligands behave as strong field ligand. Excellent. आप लोगों ने question पूछा था why? ठीक है. So the reason is as you go down the group, the size of d orbital, and hence even if it's a WFL, the approach of ligand along the axis, but the size is so large that repulsion or repulsive forces increase. Simple terms with down the group, CFSC increases. So out of the three, सबसे ज़्यादा CFSC will belong to iridium, then rhodium, and then cobalt. Did people get that? बोलो रे. The last homework question. So the last question, arrange in increasing order of wavelength absorbed. I want this homework, but एक hint दे देते हैं. We know that E is inversely proportional to lambda. E is Hc by lambda. So stronger the ligand, smaller will be the wavelength absorbed. कुछ याद आ रहा है? Sorry. Did you people get that? So I want this to be done as homework.
Which one?
The last, yeah. Jaldi jaldi. Okay. Now we continue with nomenclature of coordination compounds. There are some rules. अब वो ना example करते करते I'll give you the rules भी. वो रूल्स स्टेटमेंट वाइज आप वापस से वीडियो देख के लिख लेना, ठीक है। बट नॉमेनक्लेचर एकदम इजी, सबसे इजी टॉपिक ऐसे जल्दी जल्दी करेंगे। रूल नंबर 1, यू ऑलवेज गो फ्रॉम लेफ्ट टू राइट while naming a compound, ठीक है, which is like सब जगह वैसे करते हैं, लेफ्ट टू राइट ही जाते हैं। So when you start from here left, what do you first see? Potassium. So you just write potassium. It is K4, there's no need to write tetra potassium, ठीक है, you just write potassium. After potassium complex चालू होता है। Rule number 2, inside the complex you always start by naming the ligand, add a suitable prefix to the ligand depending upon the number of ligands which are present. इसका मतलब क्या है? We get inside the complex, which is the ligand over here? Cyano, cyanido. How many cyanido are there? 6. तो क्या आएगा? Hexa cyano or hexacyanido. With me? Now, what is the metal, central metal atom that you have? Iron. So we write ferrous. But rule number 3, if the complex is anionic, I repeat, rule number 3, if the complex is anionic, you add ATE to the name of the metal. 8. Ferrous becomes ferrate. And then in round brackets, you add the oxidation number, primary valency. Oxidation number क्या है Fe का यहाँ पे? +2. So in Roman letters you write, that's the nomenclature. Samjha? Let's do the second one. Again, you start from the left. The moment you start from the left, you first encounter the complex. Inside the complex, you start by writing the name of the ligand. So which ligand do we have? Amine. How many? So hexaamine. Correct? It is a cationic complex. So the name of the metal as it is. क्या है वो? Cobalt. What is the charge on cobalt, people over here? Excellent. 3. And then no need to write trichloride. See, the charge balances the ionizable part. Did you get that? यही अगर मैं लिखता hexaamine cobalt 2 chloride. So give me the structure. What difference will you observe? This will become CO NH3 6 but Cl2. Are you people getting that? या इधर में लिखते पोटेशियम हेक्सासाइनोफेरेट 3 K3FeCN6. Are you people getting that? Ionizable part manages itself by the oxidation number. Next, third wala. Over here what we observe is there are multiple ligands. What is the first ligand that we see? Bromido, bromo or bromido. What is the second? Amine. Third, chloro, chlorido. Fourth, iodo, iodido. Yes or no? In case of such heteroleptic complexes, we follow alphabetical order. What will come first? So you start with amine, then bromo, chloro, Iodo. Is it a cationic complex or an anionic complex? Complex पे charge दिख रहा है. So platinate. What is the charge? -1, -1, -3. So हो जाएगा +2. Also, this is in the form of an ion. तो end में आप add करते हो word ION. Ion. Did you will get that? बोलो रे. Yes or no? Any questions still here? -1, -1, -1. So x -3 is equal to -1, x is equal to plus ATE. When the complex is anionic complex, you add ATE to the name of the central metal atom. With me till here? Now pay attention. ये वाला थोड़ा सा अलग है. Which is the first ligand that you have here? Ethylene diamine. How many ethylene diamines do we have? So we should add diethylene diamine. ऐसा लगता है that we should add diethylene diamine, but no. If you add a di in front of that, the ligand itself changes. So, next rule. In cases where the name of the ligand itself contains di, tri, tetra, for example, dipyridine. I repeat, in case where the ligand ka name itself contains di, what we do is, if the ligand is repeating twice, we add the prefix bis. If the ligand is repeating thrice, tris. If the ligand is repeating 4 times, not tetris, tetrakis. Samjha? So, En here is repeating how many times? तो हम क्या लिखेंगे? बिस. समझा? इसके नाम के आगे क्या कह रहे? बिस. Which is the ligand here? So dibromo. Second thing, observe the bis and the D of the di is not considered in the initial alphabetical pattern. आप ligand के नाम के alphabet से start करोगे. So the B comes first and then E. वापस से. So bis, dibromo, bis, ethylene diamine, cobalt. What do you have after cobalt? Charge here is 3 and fluoride. Anyone who can try this? Tris, ethylene diamine, cobalt, 3. Alphabetically, what comes first? Chlorine. It's not a ligand. It's outside. It's ionizable part. Chloride sulfate. Any questions over there?
If it's balancing SO4, then should it be 2?
Why?
Cobalt.
Okay. Sixth wala. Now, if you look at the sixth wala carefully, the cationic part is a complex. The anionic part is also a complex. Multiple metal, multiple ligand complex. इनका एक स्पेसिफिक पैटर्न है. We will give arbitrary charges to the cationic part and to the anionic part in such a way that both the metals should have the same oxidation state. Matlab, I start by giving the cationic part a +1, so the anionic part will get -1. Now tell me, this is +1. What is the charge on cobalt? Because amine is 0 and cyano is -1. What's the charge on cobalt? +1. What's the charge on chromium? +5. Is it same? So +1 doesn't work. So from +1 now we move on to +2, -2. Now tell me, if I put a +2, what's the charge on cobalt? What's the charge on chromium? +4. Is it same? Nope, doesn't work. Again, +3, -3. Now tell me, yes or no? That's the arbitrary charges. Samjha? Chalo, then let's start. The pattern or the rules remain the same. You start from the left. The moment you start from the left, you first encounter a complex. Inside the complex, you start by writing the name of the ligand. Hexaamine cobalt. What is the charge on cobalt? 3. Then comes वापस से hexacyanidocyanochromate. Why chromate? And the charge is again no. आयन तब होता है जब और you have just ऐसा. What about here? Same type, इसलिए I've given one more question of the same type. What will the arbitrary charges, cationic and anionic charge क्या रहेगा? Someone tell me that first. I start with +1 and -1. If I put +1 here, what's the charge on PT? +1. But what's the charge on copper? +3. So does +1 -1 work? Then we go to +2 and now tell me it works. Yes. Chalo naam likhte. Start from the left. What do you first see? So tetraamine platinum. ब्रैकेट में क्या आएगा? 2. कंटिन्यू होना चाहिए. मैं नीचे लिख रहा हूँ टेट्रा क्लोरो क्यूपरेट. ठीक है, क्यूपरेट 2. समझ? The last one. Let's start. Charge on ethylene. Cobalt, I don't know, so I put a X. What is NH2? Excellent. Amido. Charge on amido. What is OH? Hydroxo or hydroxido. Charge again. -1. Cobalt is X. Ethylene I'm in 0. Sulfate is -2. So can someone find the charge on cobalt for me? 0 plus X -1 -1 plus X plus 0 plus 2 into -2. How much is X over here? Excellent. Plus 3. तो कोबाल्ट पे चार्ज क्या है पीपल? +3 and +3. चलो, let's write the name. We start from left. What do you see left में सबसे पहला? How many? So bis. Ethylene. Diamine. Then cobalt. Charge on cobalt? 3. Cobalt 3. Now these are called as, if you remember, bridging ligands. They are represented as mu. So mu alphabetically amido, mu, hydroxido. दोनों का नाम लिखा. वापस से, what do you see there? And last, sulfate. Iyer. Venugopal Iyer. Muthuswamy Chinnaswamy Venugopal Iyer. Did you get that?
No.
Did you get that? Any questions over there? वो दोनों polynuclear आप करोगे as homework. अरे स्क्रीनशॉट ले लो. चलो, please write down organometallic compounds. Organometallic compounds. Compounds containing metal carbon bond. Compounds containing metal carbon bond are known as organometallic compounds. इनके examples and applications now we'll write together. Around applications of OMCs, organometallic compounds. Applications of OMCs. First, as a reagent, for example, copy the examples on the board. Second, as a catalyst. Anyone remembers the name of this catalyst? Wilkinson's catalyst. Triphenyl phosphine है वो, rhodium and chloro. Wilkinson's catalyst, remember, used in hydrogenation. Wilkinson's catalyst. Third, as a drug. Anyone remembers that anti-cancer drug? Cisplatin. Anti-cancer drug which is cisplatin. And the last one as an additive. As an additive. Tetraethyl lead. Tetraethyl lead. ब्रैकेट में राइट डाउन एंटी नॉकिंग एजेंट. एंटी नॉकिंग एजेंट added in fuel. Next write down note. Cyanides and carbides. एग्जाम्पल बोर्ड पे भी है. Cyanides and carbides are not OMCs. They are inorganic compounds prepared in lab. Inorganic compounds prepared in lab where the properties of these do not match with OMCs. Properties of these do not match with OMCs. ठीक है, this was a basic छोटा सा introduction to OMC. However, we still have to do छोटा सा half an hour to 45 minutes का part on this, which is synergic bonding. थोड़ा सा about non-classical ligands. We have something called as sigma donors, pi acceptors, pi donor, pi acceptor ligands, which are non-classical ligands. उसके बाद एकदम छोटा छोटा bits and pieces of 10 minutes का topics are left. Colors in coordination compounds, something which we have already done, but फिर से करेंगे. So by tomorrow we will complete the chapter. ठीक है? We will have one more lecture जिसमें we'll do all questions इसका. ठीक है?